Natural numbers n. So let's begin our discussion on natural numbers. Welcome to the first slide titled Natural Numbers. As you know, in mathematics, we don't just work with numbers randomly. We like to organize them, to group them based on their characteristics, things they have in common. We call these groups sets. Think of it like sorting objects. You might put all the red objects in one group and all the blue objects in another. Now, one of the most basic and important sets in all of mathematics is the set of natural numbers. These are the numbers we use almost instinctively when we start counting. Over the course of this tutorial, we're going to really nail down what exactly defines natural numbers. We'll look at a precise definition, and we'll work through several examples to make sure you can confidently identify them. We'll also cover some common pitfalls students often encounter, so you can avoid making those mistakes. So, let's get started with building a solid foundation for understanding these fundamental building blocks of mathematics. Definition of natural numbers. So let's move on to formally defining what natural numbers are. As we discussed on the previous slide, these are the numbers we intuitively use for counting. This slide starts with the heading definition. Now, natural numbers are the set of positive integers, and they begin with 1. Think about it, when you start counting, you say 1, 2, 3, and so on. These are your natural numbers. They're the building blocks for all other numbers, really. They are, quite simply, the numbers we use for counting things: apples, fingers, students in a class, anything you can quantify. Now, mathematicians like to be very precise, so we have a formal way of writing down the set of natural numbers. We use a special notation for this. It's written as n, and it's represented by a capital letter with a double bar through it. We call this the set of n, and it's defined as 1, 2, 3, 4, 5, and so on, continuing infinitely. The 3 dots ellipsis indicate that the pattern continues forever. It's important to note something that often trips students up. 0 is not included in the set of natural numbers. While it's true that some mathematicians do include 0 in their definition of natural numbers, for the purposes of this tutorial, and in many common mathematical contexts, we will stick to the definition that excludes 0. It's a convention, a rule we agree on to avoid confusion. We'll be consistently using this definition throughout our work, so it's crucial you remember that natural numbers start at 1, not 0. We'll reinforce this as we go through more examples and concepts, and we'll also touch on how natural numbers differ from other sets of numbers like whole numbers on a later slide. Examples of natural numbers. Let's move on to some examples to really solidify our understanding of natural numbers. As we discussed earlier, remember that natural numbers are positive whole numbers starting from 1. We represent the set of natural numbers with a special symbol, which is a capital N with a double bar. We say n double bar, and it looks like this: 1, 2, 3, and so on, continuing infinitely. Now let's look at our first example. Is 5 a natural number? The first thing we do is check if 5 is a positive integer. Well, yes, it is. It's a whole number and it's greater than 0. Next, we check if it fits the pattern of our set of natural numbers: 1, 2, 3, and so on. Does 5 fit in there? Absolutely. So the conclusion is yes, 5 is a natural number. Pretty straightforward, right? Let's try a slightly different one. Example 2, is -3 a natural number? Again, step 1, is a positive integer? No, it's a negative integer. Because it's not positive, it immediately doesn't fit our definition of a natural number. So the conclusion is no, -3 is not a natural number. Remember, natural numbers are about counting, and you can't count with negative values. Now this is a common one where students sometimes get tripped up. Example 3, is 0 a natural number? Step 1, is 0 a positive integer? No, 0 is neither positive nor negative, it's neutral. And as we established on the previous slide, our definition of natural numbers specifically states they start at 1. Therefore, the conclusion is no, 0 is not a natural number. It's important to keep that distinction clear. Finally, let's look at example 4. Is 100 a natural number? Step 1, is 100 a positive integer? Yes, it is. It's a whole number and it's greater than 0. Step 2, does it fit the pattern of the set of natural numbers? Yes, it certainly does. It continues the sequence, 1, 2, 3, all the way up to 100 and beyond. So the conclusion is yes, 100 is a natural number. These examples should give you a good feel for identifying natural numbers. Remember, the key is to always ask yourself, is it a positive whole number starting from 1? If the answer is yes, then it's a natural number. We'll build on this understanding in the next slides, so make sure you've got a firm grasp of these examples before we move on. Key takeaways. Let's recap what we've learned about natural numbers. This slide, titled Key Takeaways, summarizes the most important points. Firstly, natural numbers are, at their core, positive integers that we use for counting. Think about it, when you start counting objects, you begin with 1, 2, 3, and so on. These are natural numbers. Next, we represent the set of all natural numbers with a special symbol. It's written as a capital N with a double bar through it, we say N double bar, and is equal to the list of numbers starting from 1, 1, 2, 3, 4, 5, and it continues infinitely. We write it as 1, 2, 3, 4, 5, with an ellipsis, those 3 dots, to show that the pattern goes on forever. Finally, and this is crucial, remember that 0 and negative numbers are not included in the set of natural numbers. We've emphasized this throughout the tutorial, and it's a common point of confusion. Natural numbers are strictly positive whole numbers. Keep these takeaways in mind, as we'll build on this foundation when we discuss other types of numbers, like whole numbers and integers, in future lessons. Also, remember to always refer back to the definition if you're ever unsure whether a particular number is a natural number. Now, let's move on to the next slide, where we'll address some common mistakes students make when working with natural numbers. Common mistakes. So, the first point here says, a common mistake is to include 0 or negative numbers in the set of natural numbers. Now, we've spent the last few slides specifically defining what natural numbers are, and we've emphasized that they begin at 1. It's easy to fall into the trap of thinking about counting starting from 0, especially when you're first learning about numbers. But remember, for the purpose of this tutorial, and in many mathematical contexts, 0 and any negative numbers are not considered natural numbers. Next, it says, remember the definition. Natural numbers start at 1 and consist only of positive whole numbers. This is your key takeaway. If you ever get stuck, always go back to this definition. Natural numbers are simply the positive integers we use for counting, 1, 2, 3, and so on. The slide then points out, another mistake is to confuse natural numbers with whole numbers, which do include 0. This is a very frequent error. Whole numbers are the natural numbers plus 0. So, the set of whole numbers would be 0, 1, 2, 3, and so on. See the difference? Natural numbers exclude 0, while whole numbers include it. We'll likely cover whole numbers in a future tutorial, but it's good to be aware of how they differ right now. Finally, the slide states, always refer back to the definition to ensure you are correctly identifying natural numbers. This is excellent advice for any mathematical concept. When in doubt, revisit the foundational definition. It's the most reliable way to avoid errors and build a strong understanding. Let's move on to the final slide, which covers common mistakes students often make when working with natural numbers. This is really important to solidify your understanding. And that concludes our tutorial on natural numbers. Hopefully, you now have a clear understanding of what they are, how they're defined, and how to avoid common mistakes. Remember to practice identifying natural numbers to reinforce your learning.